In this video, I will explain you what is solar cell. So solar cell is also application of PN junction diode. Okay. Now, why we are using solar cell? To convert the available source of available power, which is everywhere on the surface of earth at free of cost. What is that? Solar power. So during daytime we have light energy coming from sun on one side of the hemisphere. One side of the earth we have solar energy available, but this side we have no availability of solar side. So this side would be day, this would be night. So in night time, in daytime we have availability of solar energy, and this solar energy are only consumed by plants as of now for the process of photosynthesis that will make food using the energy available with the sunlight. Okay, now why can't we use this same energy for our day-to-day activities? For example, for running a car. If a car is powered by solar, then it is very easy that in daytime we can store energy by converting solar energy into electrical energy. In battery we can do that if we are providing solar cells with a car, then this solar cell would convert energy available in the sunlight into electrical energy, and this electrical energy can be stored in battery. So this energy can be used for the engine to run or the motor to run, which will drive the car. And also this can be used in house. Okay, so if we are keeping a solar cell, see, the solar cell also always have to be exposed with sunlight, then only it can convert the solar energy into electrical energy. So if our house is provided with solar cells during daytime, it would be converting the solar energy into electrical energy, and that can be stored. And during night and also in the daytime we can use this energy, and the excess energy would be stored in the battery. During the night we can make use of the stored energy. There are multiple. In Kerala we have one airport which is Cochin Airport, which is fully powered by solar energy. Okay, so what I am saying is solar energy has great significance in this energy and in this generation, and has got a huge significance in coming generation, where the availability of non-renewable source of energy is very less. For example, fossil fuel and other energy sources. Okay, so at that time even the electrical energy is a renewable source of energy, like the one which we are using, which we are making at AC generators of powerhouse. What we are doing, we are storing the water at higher energy, higher potential in dam, and this is stored in the potential energy of water, that is now converted into kinetic energy as it comes down, and this kinetic energy is being converted at the turbine as mechanical energy, and this mechanical energy is now given to a rotor which is rotating in magnetic flux, and this will give a AC output. But anyway, here this is an energy conversion, but anyway here this cannot be used this can only be used when it is available with water at a particular level. Now the level of water is less, then we can't run a turbine with a lower potential energy available. And also in steam turbine we are basically burning coal, and this energy is given into steam, and that steam is now being converted. That steam is used in turbine to generate energy. So wherever we are generating electrical energy, some or another way we are going to use the non-renewable form of energy. And some places these are non-renewable form, but the thing is this cannot be run at all the climates, okay, all the season. At summer season the water level would be less, so this application or power generated would be less. When the water available is more, we have higher application, or we can generate higher amount of power. So anyway, in short, what I am saying is, if we are making use of solar power, then that would deliver energy across all the season, but only in the daytime, because in daytime we have availability of solar energy. Okay, now how can we make use of solar power, solar energy? So we will make a PN junction in this way, where the thickness of P type semiconductor would be very less, and this would be thick, N type would be thick, and on the bottom of N type we have a metallic plate, and on the top of P type we have a metallic collector. But see, here it is completely filled. So in the bottom, if you are seeing, the metallic plate covers the whole area, but on the top the metallic plate, this is silver strips, so these are only covering less than 14% of the total area. I will tell you why. So these are silver arms, okay, like this. Why? See, this is kept only for only with 14%, because we need these areas to be exposed with light. Now I'll tell you the working. See, the light energy will come. So if the light energy is directly hitting the light radiations, if it is directly hitting this silver strips, then that will not do any energy conversion. That will simply heat the silver stripe. Okay, but when the light is passing through, when the light reaches p-type semiconductor, as the area is very thin, now this can move to the junction, this can reach the junction. So a lot of energy, I can say, as 85% is exposed to light. Whenever the light falls on this area, that will go till PN junction, and at PN junction what will happen? We have a PN junction here. Now I have told you, near to P we have negative charge. This is due to I am talking about the depletion region. Here we have positive charges. So with N we have electrons as majority carriers, with P we have holes as majority carriers, but on depletion this will become positive charge and this will become negative charge. Now when the light ray falls on the depletion region, what will happen? Electron hole pairs would be generated, electron hole. Now this hole would be attracted by this positive charge and would be taken to, so these electrons would be attracted by the positive charge and would be collected in the N-type semiconductor. And what will happen to the hole? It would be attracted by the negative charge here, and that would be collected at P-type semiconductor. Once again I will repeat, an electron and a hole. See, this is electron, this one is electron, and this one is hole. An electron hole pair is generated, and what is the reason? The light is having sufficient energy and this will do work function. Work function is nothing but taking an electron from the valence atom. Okay, now this will give energy to the valence electron, and this electron become free, and these are free electron, these are hole. A hole is generated, at the same time an electron will also be generated. Whenever there is a generation of electron, that would be associated with generation of hole. I'll give you the idea here. Silicon, 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 double bond, double bond, double bond. So not double bond, sharing of electron. Okay, So when light falls here, electrons will come out, free electron, and that will also generate a hole. So electron hole pairs are generated. This will try to recombine, but what will happen? Immediately that is being generated, these holes are pushed to p-type and these electrons are pushed to n-type, because electrons will be repelled by the negative charge and also be attracted by the positive charge. It will come down and holes will go up, because these are repelled by the positive charge and attracted by the negative charge, that will go up. I will make it a big picture. Depletion region, negative charge with P and positive charge with N. Electron hole pair generation, electron is taken here on attraction with positive polarity. Now holes are taken here on attraction with negative polarity, and also effect of repulsion due to positive charge. Now holes are being accumulated here, electrons are being accumulated here. Now the electron will immediately go to the metallic conductor, because with metal, if it is keeping with metal, then it is having the ability to move across, because metals has got lower resistance. So whenever it sees a metal, it will go towards the metal. So in this metal, electrons would be collected. So electrons are now collected here. Now at the same time, we have a metallic strip here made up of silver. Holes would be collected on the top. So these holes in the p-type, that would go to the nearby metallic strip, because that silver has got a very less resistance. Lower the resistance, charges will show more affinity towards low resistive path. Okay. Now holes are connected in this silver arm and electrons are connected here. Now when we are taking a connection from these two metallic plate, it is having a positive polarity and this is having a negative polarity. When this is connected across a load, current will flow in this direction. Okay. Now this can also be connected to a battery to store energy. So anyway, electron hole pairs are generated using the light energy. So light energy is now converted into electrical energy. These electrical energies are stored here. On closing the circuit, electrical energy will move through the circuit, or this can also be stored in a battery. So this is solar cell. Now solar cell, the graph of the solar cell I will represent here. Solar cell is not provided with any battery, because this acts as a cell. It doesn't need a cell to operate. Okay. Now when there is no current, when the circuit is open, all holes would be connected here, all electron will be collected here, having the maximum potential difference across it. Now the moment current is passing through it, we know that V is equal to E minus IR. Now higher the current, lower would be the terminal voltage. Let's say the current is 0 now terminal voltage would be equal to EMF. As current increases, when we close the circuit, what will happen? Current will move and voltage will decrease, because this will increase in this value is nothing but a deduction. Increase in this value will reduce the whole value, because this is 5 minus x. Now x is 1, the value would be 4. If x is 2, the value would be 3. So similarly, as increasing this value, the total value would decrease. So on increasing current, the voltage would decrease, and on maximum current, the voltage would be 0. So this is V and this is I. This is the graph of solar cell. Now this is very important, the working principle of solar cell. Okay, thank you.